Imagine standing on the edge of Pluto. Above you, the sun isn't a blazing disk anymore. It's just a bright star, cold and distant, barely strong enough to cast a shadow. Around you, frozen plains stretch out in every direction, silent under a faint blue haze. No wind you can hear, no movement you'd expect, just stillness, the kind of stillness that makes you believe nothing has changed here in billions of years. That's the Pluto most people still picture. A dead rock at the edge of everything. Forgotten, frozen, finished. James Webb just proved that picture wrong. If you're fascinated by the greatest mysteries of space and the universe, subscribe to Beyond Cosmos, because every week we explore stories that completely change the way you see the cosmos. Now let's begin. When Pluto was discovered in 1930, it captured the public imagination almost instantly. A ninth planet, sitting alone at the far edge of everything we knew, impossibly distant and impossibly mysterious. For decades, it held that title proudly. Then, in 2006, astronomers redefined what a planet actually is, and Pluto no longer fit the definition. It was reclassified as a dwarf planet. Overnight, the world that had captivated generations became, in the eyes of many, a footnote, a demoted planet, a tiny, frozen leftover not worth another glance. That assumption held for years. Scientists largely treated Pluto as settled science, a cold ball of ice and rock too small and too distant to hold any real surprises. Then, in 2015, a spacecraft called New Horizons finally reached it after a 9-year journey across the solar system, and within days, everything changed. Nobody expected what the cameras revealed. Instead of a dead, cratered surface, New Horizons showed mountains made of water ice, rising kilometers into a thin, hazy sky. It revealed vast plains of nitrogen ice so smooth and so free of craters that they had to be geologically young, meaning something on Pluto had resurfaced them recently, at least on a cosmic timescale. It revealed a pale blue atmosphere, extending much farther into space than anyone had predicted. And at the center of it all, a massive, heart-shaped region that would soon become the most recognizable feature in the outer solar system, a formation called Sputnik Planitia. Pluto wasn't dead. It was, in some strange and quiet way, still alive. But that wasn't the biggest surprise. New Horizons only gave scientists a single brief look, a flyby lasting mere hours before the spacecraft continued on into the darkness beyond. It showed researchers what Pluto looked like. It couldn't explain why Pluto behaved the way it did, and that gap between seeing and understanding would stay open for almost a decade. Then James Webb revealed something nobody expected. Unlike New Horizons, Webb isn't a camera flying past a world and snapping pictures. It's an infrared telescope built to detect heat, chemistry, and the invisible signatures molecules leave behind. Where a normal camera captures light we can see, Webb studies wavelengths our eyes were never built to notice. That difference matters enormously because it lets scientists answer a question no photograph ever could. Not just what does Pluto look like, but what is actually happening inside its atmosphere. And what Webb found rewrote the story completely. For years, scientists had proposed a strange idea about Pluto's thin blue haze, the same haze that gives its sky that unmistakable color. They suspected it wasn't just a visual feature drifting passively above the surface. They suspected it was actively controlling Pluto's climate, but the idea remained unconfirmed, a hypothesis waiting for better data. Webb's observations confirmed it. Pluto's high-altitude haze absorbs sunlight, and then, instead of trapping that heat the way greenhouse gases do on Earth, it radiates the energy back out into space as infrared light, cooling the atmosphere in the process. It's almost the opposite of what we experience here. On Earth, our atmosphere holds heat in. On Pluto, its haze pushes heat away, acting like a thermostat that no other known world in our solar system uses in quite the same way. Pluto, sitting at the coldest, darkest edge of the solar system, is cooling itself using something that looks almost like smog. But the strangest discovery wasn't only in the chemistry of that haze, it was in what that haze made possible. Because Pluto has something else most people never expect from a frozen dwarf world. It has seasons. Pluto's orbit around the Sun takes 248 Earth years to complete, an orbit so long that an entire human lifetime is only a small fraction of a single Pluto year. As it travels along that immense path, its distance from the Sun changes dramatically, and so does the temperature of its surface ice. When Pluto is closer to the Sun, some of its frozen nitrogen sublimates directly into gas, thickening its thin atmosphere. As it drifts farther away again, that same nitrogen begins freezing back onto the surface, and the atmosphere collapses inward, thinning dramatically. A world we once imagined as permanently, unchangingly frozen is, in its own extremely slow way, breathing. That's when scientists realized everything they believed about small, distant worlds might need to be reconsidered. Because if Pluto's atmosphere behaves this dynamically, what else might be happening beneath its frozen crust? This is where the science shifts from confirmed observation into careful, honest speculation. Researchers have found surface fractures that hint at internal stress. They've studied the position and behavior of Sputnik Planitia and modeled scenarios where the entire dwarf planet may have reoriented itself over time, something that becomes easier to explain if there's a dense, liquid layer hidden beneath the ice. All of this has led to a hypothesis, and it remains only a hypothesis, that Pluto may harbor a subsurface ocean, a hidden layer of liquid water sealed away far beneath its frozen surface. It hasn't been confirmed, but the possibility alone is enough to make you look at that quiet, icy world completely differently. And that brings us back to the heart. Not metaphorically, literally. Sputnik Planitia, the massive, bright, heart-shaped basin visible on Pluto's surface, isn't just a striking image that captured the internet's attention when New Horizons first sent it home. It's one of the youngest surfaces discovered anywhere in the solar system. It has almost no impact craters, and on a body constantly bombarded by space debris over billions of years, the absence of those scars means something has been resurfacing it recently. Scientists believe Sputnik Planitia remains geologically active even now, its nitrogen ice slowly flowing and renewing itself like a glacier here on Earth, just far colder, far slower, and far stranger. The most famous feature on Pluto was never just a symbol people fell in love with. It's physical evidence that this small, forgotten world refuses to go quietly into stillness. And that raises an uncomfortable question. How is any of this possible? Objects this small, this cold, and this far from the Sun are expected to freeze solid within their first billion years of existence and stay that way forever. Pluto has had 4.5 billion years to go completely still. Instead, it still surprises scientists with activity nobody predicted. Every answer only created a bigger mystery, and Webb isn't finished. Because Pluto isn't just a single, isolated puzzle floating in the dark. It's a doorway into an entire hidden region of our solar system called the Kuiper Belt, a vast collection of icy, ancient objects far beyond Neptune's orbit. In its earliest years of operation, Webb managed to capture detailed spectra, essentially chemical fingerprints, for more than 75 of these distant trans-Neptunian objects. Among them, scientists identified 3 previously unknown surface composition classes, entirely new categories of material nobody had documented before. Pluto isn't just a strange world on its own. It's a window into the earliest, coldest chapter of our solar system's history, a chapter that's only beginning to be read. So why does any of this feel unsettling? Not because Pluto is dangerous. It poses no threat to anyone. It's unsettling because it keeps forcing scientists to rewrite what they thought they understood about small, icy, distant worlds. Every mission, every observation, every new wavelength of light we study seems to reveal that Pluto follows its own rules we're still only beginning to decode. There was a time, not long ago, when Pluto was treated as a solved case. Discovered, visited, categorized, and quietly set aside. a world people used to call, almost dismissively, the forgotten planet. That title no longer fits. Today, Pluto stands as one of the most important natural laboratories we have for understanding how small worlds form, how thin atmospheres survive and evolve, and how activity can persist in places we once assumed were locked in permanent silence. It's teaching us that distance and size don't determine whether a world still has secrets left to reveal. Sometimes the smallest, quietest places in the solar system are hiding its biggest mysteries, waiting patiently at the edge of the dark for someone, someday, to finally look closely enough to notice. And perhaps that's the real lesson Pluto keeps offering us. The farther we look into space, the stranger even the most familiar worlds become. We thought we already knew this small, cold, distant place. We were wrong, and somewhere out there, in the quiet blue haze above a world we once gave up on, there is still so much left to understand.